So again, we did these, we solved algebraically on the board, and just remembering when you take the square root of something squared plus or minus. That was the big idea there. And then we did these using the Xbox method as a refresher on how to do that factoring there. Well, in the previous problem also we did that one where it was practicing with the quadratic formula. Make sure that if you don't have it memorized, you have that on your formula sheet that you can have for the second exam, just like you could for the first exam. Anything you want on it, formulas, example problems. If you do example problems on your formula sheet, my recommendation always is have little arrows and actually words describing what's happening. Otherwise, you're going to get there and go, I don't remember what, like I wrote this down in the heat of the moment taking your exam going, what was I doing? The procedures are what we need to be focusing on. All right, and then what happens if you can't factor it like we just did? Then we can use the method called completing the square. So we'll do that one here quick on this first one. So in the completing the square, the first step is we actually move the constant to the other side. Since 4 is equal to 4, I add 4 to both sides, so now it equals 4. And then what I do is I take half of the middle term. So here's the middle term, 2. I take half of 2, which is 1. And I'm going to erase this here for a second. There we go. Half of the middle term is 1. I'm going to add that and square it to both sides. So on the right-hand side, we had 4. To that, I'm going to add 1 squared. So again, it's half of the middle term. Square it, add it to both sides. So on the left, then I have x squared plus 2x plus 1. On the right-hand side, I have 5. And the reason why, now really what I have here, if I keep thinking about this as 1 squared, the left-hand side factors into x plus 1 and x plus 1. Again, thinking, what two numbers multiply to positive 1 that also add to positive 2? That's 1 and 1. They'll be the same number if I'm doing complete the square the right way. 1 squared, that number that's being squared is the same number that is down here. This equals 5. X plus 1 squared, because something times itself is squared. And now it looks like the slide that we did to start today. If I want to solve for x, I have to get rid of the square. How do I get rid of the square? I square root both sides. On the left-hand side, the square and the square root are inverse operations, leaving me with x plus 1. On the right-hand side, when I take the square root of something squared, it's plus or minus the square root of 5. To solve for x, need to get rid of the 1. I will subtract 1 from both sides, leaving me with x equals negative 1 plus or minus the square root of 5. And that is finished. Could also have done the quadratic formula, but because it says here, complete the square. So when we get to the exam, if it tells you how to solve, that's the method you need to solve with. If it says use complete the square method, then you show me that you can do complete the square method. If it says use quadratic formula, then you show me that you can use quadratic formula. So same idea here. We'll do the second one a little bit quicker. 2x squared minus 4x. I'm going to add 20 to both sides. So move that 20 over by adding 20 to both sides. And then I'm going to take half of the middle term. So there's the middle term. Half of it is negative 2. Squared, I'm going to add that to both sides. Over here, I'm going to add negative 2 squared. And there's a reason why I left it written as negative 2 squared on the left. Ooh, before I do that, see, I do this all the time. We're going to go back and fix my problem. 2x squared minus 4x equals 20. I forgot to get rid of the first term. What do I mean by that? not get rid of it. This needs to be 1, not 2x squared. So if I have 2x squared, I got to figure out how do I get rid of this 2? And it's a positive 2 no matter how much it might look like that's a negative. How do I get rid of a 2x squared? Well, that's multiplying, so the way to get rid of something that's multiplied is I divide everything by 2. X squared minus, there's an x right there, 2x equals 10. Now I can do completing the square, where I take half of the middle term and add, so negative 1 squared. On the right-hand side, I'm going to add negative 1 squared. Half of the middle term, square it. Half of negative 2 is negative 1, square it. X minus 1 squared. So I skipped a step. This number here, this negative 1, that's what this is inside of here. So it's x minus 1. And again, because we're thinking, what two numbers multiply to positive 1, negative 1 squared is positive 1, add to negative 2, negative 1 and negative 1. This equals 11. Square root both sides. X minus 1 equals the plus or minus the square root of 11. Add 1 to both sides. X equals 1 plus or minus the square root of 11. And again, if you did the quadratic formula, you would get to that same answer as well. It would just take some time. For this one, what method do you think would be the easiest? X box, possibly, if it's factorable. The hard part with X box is if it's not factorable, you spend a lot of time going, that wasn't very good. Well, if we do completing the square, 3x squared minus 9x equals negative 8, subtracted 8 from both sides. Divide everything by 3, because I need that first term to be 1. X squared minus 3x equals negative 8/3. Don't make it into a decimal, leave them as fractions. I take that middle term, and I'm going to add to both sides the same thing. So I'm going to take that middle term and take it in half and square it. On the right-hand side, I take, again, whatever you do to one side, I have to do to the other side. Half of the middle term and square it. On the left, I will be left with x minus 3/2. Again, this number is what half of the middle term was. That's why we're doing it. So it's x minus 3/2 squared. And this will equal, let's see up here, negative 8/3 plus 9/4. 3/2 times 3/2 is 9/4. I have to convert into twelfths. Negative 32 twelfths plus 9 times 3 is 27 twelfths. That will be negative 5 twelfths. If I'm doing that in my head correctly. Square root. X minus 3/2 equals plus or minus square root of negative 5 twelfths. Add 3/2 to both sides. 3/2 plus or minus the square root of negative 5 over 12.
If you can't, like...
So we get to here. The other thing at this point, though, we're also going to look and say this nugget, this piece, we don't like having, so I'm going to rewrite it as the square root of negative 5 over the square root of 12. All right. We don't like having 12 in the like a square root in the denominator. So I'm going to multiply this by 1. We did this last time we met, I think. What's called rationalize the denominator. The one I'm going to choose is the square root of 12 over the square root of 12. Anything divided by itself is 1. And when I do that, square root of 12 times the square root of 12 is 12. So in the top, I'll have the square root of negative 60 over 12. This 3/2 still exists out in front, plus or minus. And then at that point, you're more or less done. This 60 can be simplified in simplified radical form. If I do it over here.
If we were to stop at like the green, we'd still get a 3, right?
Yes. Yeah. Negative square root of 60 splits into negative 1 and 60. And then 60 is divisible by 4. Square root of 4 times square root of 15. 15 times 4 is 60. Square root of 4 is 2. The I, well, that's I. And then 15 is not divisible by 4 or 9. So the square root of negative 60 is equal to those three things, here, here, and here, together multiplied 2I square root of 15. So now my fraction is 3/2 plus or minus 2I square root of 15 over 12. Last thing would be seeing that these two reduce. 3/2 plus or minus I square root of 15 over 6. Then we would be, like, this would be the 100% complete polished up. If you're taking pre-calc next, you got to do this. A problem like this, if 2,000 was invested and it grew to 2420 after 2 years, compounded annually, what's the interest rate? There's the formula for it. A is the amount that you end with, 2420.
Is this going to be on the test or something similar to this?
Something similar to this, yeah. P is the principal. That's what you start with. 1 plus R. We don't know the rate because it says, what was the rate. Compounded over 2 years. Well, that's T for time. That's 2 years. Got to solve for R. Right? Now it looks like a lot of the problems we've been doing. Oh, good. I got to solve for R. Need to get rid of everything else first before I can get to the R. So the first thing I got to get rid of is the 2,000. It's the furthest away. To do that, dividing both sides by 2,000. So 2420 over 2,000. I'm not actually going to multiply that out yet because I don't want to worry about the decimals yet. 1 plus R squared. Because the 2,000s reduce. That's over here as a fraction. Now it looks like the problems we've been doing. Got to solve for R. It's inside the parentheses. The parentheses are being squared. Inverse of squaring is square rooting. And now I'd actually go to a calculator, which you'll do for me, and find 2,420 divided by 2,000, find that answer, and then take the square root of it. And that number will be 1 point something. Two, one. So is that it, or does it go further than that?
That's it. That's full. That's 2,420 divided by 2,000.
Okay, then, that's this number?
Yeah.
Okay, now take the square root of that.
1.1.
There's no more decimals after that? It's exactly 1.1.
1.1.
Okay. Equals 1 plus r. Subtract 1. R equals 0.1. Or in this case, since we're talking about an interest rate, you normally don't talk about interest rates in terms of decimals. We usually have them as percents. What is 0.1 as a percent? 10%. Which is a pretty good rate to have for annual growth. So that's the annual interest rate. If you invested $2,000 in 2 years, you have $2,420. That's very good yield, but that's because it was a 10% rate. Another type problem that we might see, object thrown upward with a velocity of 32 feet per second, which is this positive 0.332. Again, I'll give you this information and how it translates into an equation. From the top of a 200-foot cliff, the height of the object after t seconds is modeled by this equation. How long after the object is thrown will it strike the ground? In other words, what's the height when something hits the ground? What's the height when something hits the ground? What is the height when something hits the ground? So when the height is 0, that's when it hits the ground. Use completing the square or quadratic formula. What do you want to do? Tell you what I'm going to do first. I'm going to divide everything by negative 16. The reason why is now on the left I have 0. Negative 16 over negative 16 is t squared. 32 divided by negative 16 is negative 2t. And then what's 200 divided by 16? Negative 16.
Negative 12.5.
Negative 12.5. I like this a little bit better because I have smaller numbers. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'll have x equals negative b. b is negative 2, so negative b is negative a negative 2 or positive 2. Plus or minus the square root of, and I'll need people's help here. Let's see, b squared, so negative 2 squared is 4, minus 4 times a is 1. C is the last term, that's negative 12.5. All over 2 times 1. X equals 2 plus or minus the square root of 4 minus, what's 4 times, well, 4 times 1 is 4. What's negative 4 times negative 12.5? Four times plus 50?
Yeah.
All right. Again, negative times a negative is positive 50. All over 2 times 1, which is 2. So now I have 2 plus or minus the square root of 54 over 2. What's the square root of 54 equal to? Square root of 54.
$7.348.
348?
7.348.
We'll just leave it at that. So then I'm going to do 2 plus 7.348 divided by 2. and I go 2 minus 7.348 all over 2. So this is equal to 4.674. And this is negative 2.674. Back to the original equation, or original question. How long after the object is thrown will it strike the ground? Will it be 4.674 seconds or negative 2.674 seconds?
Full.
Correct. And why can't it be the other one?
Because you can't have a negative seconds.
You cannot have negative seconds. So why in my question, why is it even possible to have an answer that has negative seconds? The reason why is if I would actually graph this with time on this axis, time, height on this axis, height. At time is 0, it's at 200 feet because it says from the top of a 200-foot cliff. So what's actually happening is here is I have a parabola that goes like that. Because that first term was negative, it's an upside down parabola. This point right here is the point at which the height is 0, 4.674. And then back here in imaginary land, negative 2.674 is when theoretically if I would have launched from the ground instead of from the top of a cliff, it would have been on the ground. That is missing some components to it. I got to figure out what's missing. So that's what the original question was. So this gets us back to what we did last time we gathered. We're solving for things when x is under the square root. The first step is to get the square root by itself. To do that, I'm going to subtract x and add 6 to both sides. When I do that, I will be left with negative square root of x equals negative x plus 6. I want just the square root. To get just the square root, I'm going to divide everything by negative 1. So then I have square root of x equals x minus 6. And then it's trying to remember, how do we get rid of the square root? Inverse of square rooting is squaring. X equals x minus 6 times x minus 6. Making sure I write it that way and so I don't get caught doing something wrong with exponents. FOIL, x squared minus 12x plus 36 equals x. Now I have a quadratic. Quadratics are solved by setting equal to 0. Subtract an x from both sides. And then you would finish that using a quadratic formula or completing the square or factoring if you can. This is missing a part as well, so this would be x minus the square root of x plus 1 minus 5. Same idea, subtract x, add 5, both sides. I don't want the square root in front of the square root symbol, or sorry, I don't want the negative in front of there. So I divide everything by negative 1 or multiply everything by negative 1, either way. If I make that positive, then this changes signs and that changes signs. Procedurally, same thing. Square both sides. Squaring a square root is x plus 1 equals x minus 5 times x minus 5. FOIL, which I do quickly, x squared minus 10x plus 25 equals x plus 1. Again, I have a quadratic. Quadratics are solved by setting them equal to 0. And then you finish that up using either the quadratic formula, completing the square, or factoring. How would you go about that? What do you think?
Solve by getting, p squared by itself.
Well, I
I
don't,
get rid of the 3.
but what do I do with the p to the 4th?
Keep it.
Okay,
So then you go down, you go p to the 4th.
so in a case like this,
Wouldn't it be like two different ones, p squared?
so I could do this using the x box method.
Yeah.
P to the 4th. Down here I have negative 4. What numbers multiply to negative 4?
1,
Negative 1 and
4.
4. What else? 1 and negative 4. 2 and negative 2. Which of these adds to negative 3? Negative 1x and positive 4x. Is that what you're saying? Okay. Negative 1 plus 4. Sorry, negative 1 plus 4. That sum is positive 3. I want it to be negative 3. So I need to switch these signs. So it'll be positive 1 and negative 4x. Or this, sorry, p. But it's not p to the 4th, it's p squared. Because that middle term is p squared. Set up my box. Inside I have p to the 4th. Down here I have negative 4. I have p squared and negative 4p squared. So what two things multiply to p to the 4th? P squared and p squared.
Yeah.
And if I look at this column, p squared times what is p squared?
P.
P squared times p is p cubed. P squared times 1 is p squared. Okay? Here, p squared times what is negative 4p squared? Negative 4. And then if I did this right, does negative 4 times negative 1 equal negative 4? Yes. So as I've factored this, it's going to then be p squared minus 4, p squared plus 1 equals 0. I need two things. I have two things there. Multiplied to give me 0. What must one of these things be? Either this is equal to 0 or this is equal to 0. Because in order to multiply to get to 0, one of them must be 0. P squared minus 4 equals 0. We're going to solve for p squared. How?
Add 4 to that side.
Add 4 to both sides. How do I get rid of the squared?
And,
Square root.
yeah.
P equals
Plus or minus 4.
plus or minus 2.
'Cause you-
But good, plus or minus, don't forget, when we're square rooting something squared, have to have the plus or minus. Then over here I have p squared plus 1 equals 0.
minus 1 minus 1.
Subtract 1 from both sides. P squared equals negative 1.
Leave it up. And then you square root it.
Square root both sides. P equals
Plus or minus square root of negative 1.
and what is the square root of negative 1? I.
Would you accept the other one as well? If you don't.
And then we get slightly more complicated as our last problem for today. To do this, I need to have common denominators.
So x's.
My common denominator will have to have an x, it will have to have a 3, and it will have to have a x plus 10. So with that as my common denominator, I look at this and say, all right, well, what's missing?
The 3
The 3 and the...
x plus 10.
So I'm going to multiply that single fraction by 1. Because again, when you multiply by 1, you don't change the value, you just change how it looks. And the 1 that I'm going to multiply it by is 3 times x plus 10. 3 times x plus 10. And if I'm just going to just look at this one and carry it down. It'll be 3 times 400 times x plus 10. And all I did is just reorder the multiplying. In the bottom, I'll have 3 times the x plus 10. 3 times the x plus 10. I'm only multiplying so I can rearrange the order. And that will give me 1200 times x plus 10. All over 3x, x plus 10. Then I'm going to look at this. Say, all right, in my denominator here, what am I missing? Missing the 3x. There is the x plus 10. So this one, I'm going to multiply by a very special 1. Come on, stop moving around. And it's going to be 3x over 3x. So this plus comes down. Don't lose track of your actual symbols. 3x times 400 over 3x times x plus 10. This one, same thing. There's my denominator 3. Here's my common denominator. I'll need to multiply this by x times x plus 10. Again, that's what's missing. There's the 3, so I need this. Whatever's in the bottom is also in the top. So I then have, don't forget the equal sign, 44x times x plus 10 all over 3x times x plus 10. Now let's see, 3x times 400 is 1200x. All right, so I have all of those things. At this point, if they all have the same denominator, which they do, in order for the fractions to all be equal, that means the denominators have to be equal and the numerators have to be equal. Well, my denominators are all equal, so all I have to worry about at this point then is just the numerators. So I have an equation, 1200 x, and actually what I'm going to do here, I'm going to go ahead and do distributive property. 1200x right here, and then 1200 times 10, which will be 12,000, plus 1200x equals distributive property 44x squared plus 440x. Now I have a quadratic. To solve a quadratic, move everything over and I will set it equal to 0. Let's see, these together are 2400. So I'm going to subtract 2400x from this side. And I'm going to subtract 2400x from that side. And we're going to subtract 12,000 from this side. And I'm going to subtract 12,000 from that side. On the left, I have 0 equals 44x squared. And never trust me if I do subtraction in my head. 440 minus 2400. Negative 1,960 minus 12,000. What would be really nice is if they were all divisible by 44, but they're not. So what would I do? X box, complete the square, or quadratic formula. Well, they're all even. Anything I can do to make them smaller is helpful. They're all divisible by 4. No, sorry, 4. 0 divided by 4 is 0. This is now 11x squared minus 490x minus 3,000. At least they're slightly smaller numbers. And then, again, you could plug that in. My recommendation at that point would be to use quadratic formula. They're going to be gigantic numbers. And in a case like this, I would probably say something to the effect of round answers to the nearest hundredth usually. If I ever say to the nearest hundredth, then that means don't leave them as, just go ahead and plug it in when you get to the square roots, find those numbers, and work your way through. So these are the last check your understanding problems for this exam. So on Thursday, we'll be doing a whole bunch of review problems.
What day is the test?
The exam is next Tuesday, a week from today. Yep. Hour and a half in this room.